Myself Sticker from Aero B section, and the topic for concept video for probability and statistics are application of normal distribution. My roll number is 209518221B3. Application of normal distribution. Key concept. This section presents methods for working with normal distribution that are not standard, that is, the mean is not 0 or the standard deviation is not 1 or both. The key concept is that we can use a simple conversion that allows us to standardize any normal distribution so that that same method of previous section can be used. Conversion formula. Z is equals to x minus mu by sigma. Round Z scores to the two decimal places. Converting to a standard normal distribution. Non-standard normal distribution to standard normal distribution, we use formula Z is equals to x minus mu by sigma. Example, weights of water taxi passengers. In the chapter problem, we noted that the safe loads for a water taxi was found to be 3500 pounds. We also noted that the mean weight of the passengers was assumed to be 140 pounds. Assume the worst case, that all passengers are men. Assume all the weights of the men are normally distributed with a mean of 172 pounds and standard deviation of 29 pounds. If the one man is randomly selected, what is the probability he weighs less than 174 pounds? When we say about the count, mu is equals to 172, sigma is equals to 29, z is equals to 174 minus 172 by 29 is equal to 0.07. Here area is to left side is equal to 0.5279. Mu is equal to 172 and x is equal to 174. Here x axis denotes weight. So z is sorry, z is equal to 0, z is equal to 0.007. Example 2, for constant, mu is equal to 172, sigma is equal to 29. Here mu is equal to 172, sigma is equal to, here p of x less than 174 lbs is equal to p of z less than 0.07. Example, a philanthrologist is designing an experiment to test the effectiveness of the new training program for airport security screeners. She wanted to begin with a homogeneous group of subjects having IQ score between 85 and 125, given that IQ score are normally distributed with a mean of 100 and a standard deviation of 15, with percentage of people have IQ score between 85 and 125. Caution to keep in mind, don't confuse Z scores and areas. Z scores are distance along with the horizontal scale, but areas are the region under the normal curve. Table A22 lists Z scores in the left column and across the top rows, but areas are found in the body of the table. Choose the correct left or right side of the graph. AZ score must be negative whenever it is located in the left half of the normal distribution. Area or probabilities are positive or zero values, but they are never negative. Procedure for finding values using table A22 for formula 6 to 2. Sketch a normal distribution curve. Enter the probability or percentage in appropriate region of the graph and identify the x value being sought. Use table A2 to find the z corresponding of cumulative left area bounded by x. Reference the body of the table A2 to find the closest area for the corresponding z table. Z score. Using formula, enter the value of for u sigma and the z score found in step 2. Then solve the x. Refer the sketch of curve to verify that the solution makes sense in the context of the graph and the content of the problem. Here x is equal to z mu plus z into sigma. Another formula for 6 to 2. Example, lightest and heaviest. Using the data from the previous example to determine whatever weight separates the lightest 99.5% from the heaviest to 0.5. Here mu is equal to 172, x is equal to how much, z is equal to 0, z is equal to 2.575. Example, lightest heaviest, mu plus z into sigma, 172 plus 2.575 into 29. It gives around 246.675, around 247 rounded. mu is equals to this, x is equals to 246.675, z is equals to 0, z is equals to 2.575. Lightest and heaviest constant. The weight of the 247 pounds separates the lightest 99.5 from the heaviest 0.5. Area is equals to 0.9950. Here, when we say mu is equals to 172 and x is equals to how much? Z is equals to 0, z is equals to 2.575. Procedure for finding using table 8.2 for formula 6.2. Sketch a normal distribution curve. Enter the given probability or percentage in appropriate region of the graph and identify these values being sought. Using table A2 to find the z score corresponding to the cumulative left area bounded by x. Refer the body of the table A2 to find the closest area. Identify the corresponding z score. Using formula 6.2, enter the values of mu. Using data previous determine what weight separates the lightest 99.5 from the heaviest 0.5. X is equals to mu plus z into sigma 172 plus 2.575 into 29 246.675. Mu is equal to 172, z is equal to 0, x is equal to how much? Z is equal to 2.575. The weight of the 275 pounds separates the lightest 99.5 from the heaviest. Area is equal to 0.9950, mu is equal to 172 and z is equal to 0 and x is equal to how much? Z is equal to 2.575. We have to find it out. Thank you.